And I want to see folks. Very good. And I also want to see this in case anything comes up. Okay, very good. All right, again, hello everybody. Nice to see you all. So today we're going to talk a little bit about the process of georeferencing, which is basically bringing in an image that doesn't have any spatial information associated with it and giving it spatial coordinates. And this is particularly useful skill or ability in case you're interested in looking at change over time. So there's a whole sort of subset of remote sensing called time series analysis, where basically it's analysis of land cover change, other types of change and imagery over time. And that might be just 2 images. It might be thousands of images. Weather data and other things, in some cases they're getting satellite imagery coming in every 10, 15 minutes. And so looking at how things are changing over time, whatever the phenomena is that you're interested in, being able to deal with that is quite valuable. A lot of the data imagery that are coming in now are already, geospatially known in that they've got a projection, they've got a coordinate system, and automatically for the user, you open up the image and it's beautifully georeferenced in terms of, every pixel on there has a spatial coordinate. Older data, particularly old air photos or photos that you might collect with a regular kind of camera, it might be geotagged, that photo, say this is the location of the person when that shot was taken, but every pixel in the image may not be georeferenced. Again, that's particularly true for older air photos. So if you're trying to look at, how has helo changed from the 1960s until the present, which is sort of the case study we're going to be looking at today, you need to be able to georeference that older image. And so again, that's kind of the topic of what we're talking about today. Let me let Melissa in. So yeah, if folks are interested in change, knowing about this ability in ArcGIS is not a bad thing to have some handle on. If you do not care about the past, you only live in the present, you have no idea, then maybe this is not as valuable for you. Sometimes it helps to look in the past and see where we've been. Okay, and again, here we are talking about georeferencing. This beautiful Monday morning. Lab 2 is due tonight. If you guys have questions for me about Lab 2, happy to try to address those. On Wednesday, we're going to start Lab 3, and then Friday we're going to continue that effort. So that's kind of where we're at. The second in-class assignment has been graded, so you're welcome to check that out on La Lima. If you have any questions about that, please let me know. In general, everybody did a great job. I hope it was interesting for you guys to look at these different map projections and think about, how the same data can look totally different. It can be flipped upside down for some of the maps you guys made, based on the different map projection choices of the map project. And it's visualization, right? It's sort of changing how things appear. It's not changing the data themselves. That's an important point I just want to hammer home for you guys. But making choices about how the data appear is really important. And it's an important thing to consider and think about. It's the difference between a really elegant, sophisticated map and a map that looks like, super amateur hour, right? And so it's definitely a worthwhile thing to know about. And it also, beyond that, it can convey some things about your worldview. The map projection that has historically been used to depict, world maps is very much emphasizing the dominance of North America and Europe, right? Those things are really big and Africa is really small, right? And that is, subconsciously, making some judgments about, countries' relative place in the world, right? But there's no reason you couldn't use a different map projection that would make Africa look giant, right? And so it's all kind of about where you're coming from, and understanding those things is an important thing to at least consider, right? At least think about and consider. Okay, so let me go ahead and talk a little bit about map projections, again, building off of what we talked about last time. We were thinking about, raster data models, right? So vector and raster are sort of, images or arrays of cells. And they can be just single or multiple bands. If it's single band, it'll be a grayscale image. If it's multiple bands, it'll be an image that has color to our eyes, depending on how it's shown. And every single pixel, every single cell, it contains some kind of attribute value and location coordinates if the data are georeferenced. If the data are not georeferenced, then it's got an attribute value, but it's got a position in the grid, but it's just relative to every other pixel in the grid. It's not relative to the world. And so that location coordinates, getting that information in, that's what we're going to try to focus on today. This is an image collected from a helicopter, and it's actually part of a mosaic of images. This is called an orthomosaic. You're just looking at a subset of this, but this is looking down on the coast just north of town in an area where you've got basically a bare cliff, and that's sort of highlighted in that blue line. And if I were to move my cursor around within the ArcGIS project and I had this image up and I watched, in the lower right-hand corner, you can't see it in the screenshot I grabbed, but you would see, spatial coordinates vary as I move the mouse around, right? This image has been, it's got spatial information built in, associated with it. This image is also part of a suite of things that were derived from that helicopter flight that includes a three-dimensional topographic data set. And that's shown here with the different colors. So as you get to red, that's higher elevation. And as you get to this sort of blue and such, that's lower elevation. And then to help see that, I've put on this sort of semi-transparent hill shade, which is kind of like what that landscape would look like if the sun was shining on it. The hill shade doesn't have any meaningful data in it. It's a raster, but it just is like a visualization tool. The data which are of value are the data in the digital elevation model, the DEM, the topographic data, where every pixel value is its elevation above sea level. Hopefully that's all making sense. And if we were to draw sort of transect lines along that digital elevation model, and then we looked in a two-dimensional profile of that, we would see something that looks like this. So this black line here corresponds to this 2D profile. This is like you're looking at it from the side. And then this one down here corresponds to this one if you were looking at it from the side. And where the black line crosses the blue line, that's like the cliff top, right? And that's highlighted by these little blue circles here. All right, so this is a way to look at this digital elevation data. And I could draw all kinds of transects, and they would each be a little bit different, right? They would show these sort of different, and this project is done for Hawaii County Planning Department, and they're very interested in, for regulatory purposes, knowing where the cliff tops are, right? And so this is, well, there's where the cliff tops are, right? It can get a lot more complicated than this, but these are pretty obvious examples. And so again, these data are have geospatial coordinates associated with them. You can kind of see in this little corner down here. This is in UTM, the values over here. I think this is the Easting showing. On these transect guys, on the y-axis, the vertical axis, these values are basically above sea level, right? Above sea level. That's what we're seeing here. Okay, so the top of this guy is like 25 or 24 meters above sea level, and then dropping down into the ocean. This is another image. This is also taken from a helicopter. This is an oblique image. So if you look at this image, presumably every single pixel in here has some kind of geospatial coordinate associated with it, but it's a different kind of view. It's a different kind of thinking than if you're looking straight down, right? The shot that we were looking at before, right? Okay, like things are going to vary if everything is looking straight down. Presumably every pixel is the same size. This thing, right? There's a pixel which is at the base of this cliff, which is closer to the helicopter, is going to cover a different amount of area than a pixel way back here in one of these lawns, right? Because it's further away. It's a sort of oblique perspective. Now, this image still has, spatial information associated with it, but it's more difficult and challenging to get that spatial information in a meaningful way. We use a process called photogrammetry to do that, which we may talk about a little bit later. But if you're interested in this kind of thing, I teach remote sensing class. I'll teach you next semester. We'll get into this a whole lot more. Again, there's a cliff top line. You do some cliff transects, and they look like this. Okay, same kind of idea with the digital elevation model underneath. And now we are looking straight down through this orthomosaic where every position on here has got an X and Y coordinate. And then we've got Z values or elevation values as well for the digital elevation model. And cliff tops guys over there. Okay. So we can draw the cliff line on this image. This image was collected in the year 2021 by my group and David Okita, who was flying the helicopter. I'm interested, the county is interested in knowing how has this cliff line changed over time. And one way to do that is we can't go back in time. We don't have access to a time machine, but we can, look at these older aerial photos which were collected. And this is what a 1976 aerial photo looks like. And I don't have a digital elevation model from this 1976 air photo. All I have is the photo itself. But by looking at the shadows, by looking at some other things, I can do a pretty good job of thinking about where I think the cliff line used to be in 1976. Right? So that's what this purple line is showing right here. And I know that this photo was taken in 1976. And I know that the blue line guy was taken in 2021. And I can say, oh, it's about 5 meters difference between those guys, right? And so I can make some calculations about, average rate. Although we know that things usually collapse sporadically. It's not like a slow, steady average rate, but you can make some kinds of calculations. This is another one, right? So I kind of think the cliff side is where this purple line is showing me here. And this is where the helicopter guy says, right? So we can look at some differences and make some calculations. But this is the main question that we're focusing on for us today. How did this image from 1976 or whatever it is, how did this image get georeferenced, right? What was the process to make that happen? Because it didn't start out georeferenced. It just started out as an image, right? And so how did we get there? And that's what I'd like to basically discuss today. And the starting point is, well, where do you get the imagery in the first place, right? So you got to have an image if you want to georeference it. And a good place to find imagery is this Earth Explorer, USGS Earth Explorer. It's all one word, USGS Earth Explorer. There's other sources of imagery, but this is your federal tax dollars at work, right? The USGS has a repository of images, including old air photos, as well as newer satellite imagery and new air photos. But it's this USGS Earth Explorer. Again, there's other sources of imagery and data, but this is just a good one to kind of work with. If you want to download any data from this site to, for your projects or anything else, you can do that. It's free, right? But you'll need to log in. You'll need to create an account, and that requires you to, give your email and give a little bit of information. I don't think you're really selling your soul or anything, but I'm just telling you, if you want to download any imagery from this site, you'll need to create a login. I'm not logged in currently. And typically, you start out at this page, and you can put anything in here you want. And so, right, I've already sort of put in, let me clear this coordinates. But basically you could just say like, Hilo. And then what state? Well, state of Hawaii, right? And then you could hit enter and see what we get. And then show this guy. And here we are, Hilo, right? Hilo, Hawaii. So this is the place. You click on this guy, and there we see this guy come up. And then you can make some choices about, the type of, like, do you want to limit the amount of cloud cover? Right now, I'll take, up to 100% cloud cover, right? And that wouldn't be a very helpful image. You can also set the date range. Like, I only want to see imagery from 1850. No, there weren't even cameras in 1850, I don't think. Let's go from 1910, February 1st, 1910 until, right, you can control these things. I'm sort of showing you some stuff until 1980. Let's say February 1st, 1980. I'm just saying this stuff. All right. And then you can choose the different types of data sets you want to work with. I want to look at aerial photos that are single frames. So single frame photos or these digital ortho quads. I don't think we'll get any digital ortho quads between 1910 and 1980, but we'll see what we get. These are the two that I'm choosing. There's a bunch of other things you can choose here. And this is under aerial imagery. There's digital elevation data. There's Landsat data. There's land cover data, right? There's a whole host of different types, Sentinel imagery, UAS imagery, right? Usually there's not too much, but it's sort of growing. But in this case, I'm mostly just focused in aerial photos, single frames, all right? Between whatever my range was. And I'm going to hit results and it's going to search and it's going to pop up like, oh my goodness, right? So here are these things, right? And this one's got a lot of clouds associated with it. But this is from, I don't know how well you guys can see this, 1977, right? So on March 27, 1977, they took an image. And this first guy, it covers this area, roughly. This is the area that this guy were to cover. Usually they're organized by date. And so if you go to the very end, you'll see some imagery down. So this is from 1954, right? So this one, that 1954 image that I just highlighted right there, that covers that area. It's from 1954, right? That's a pretty long time ago. The scale numbers that are shown down here, this is 33,000. This is like the map scale number. Basically, the more detailed the lower the number. So you want those numbers to be as low as possible because they'll be more detailed. So this is like a 1 to 64,000. That means that, 1 inch on the map will equal 64,000 inches in the real world. This is a 1 to 33,000. So 1 inch on the image would equal 33,000 images in the real world, for example. You can click on this guy. You can check it out. This is what it looks like, right? You can see the airport. You can see, the break wall had been established. Maybe this isn't the best one, but not a whole lot of development has occurred yet in this time frame. And then if you wanted this guy and you were logged in, you would be able to basically download it. But, and this is critical, that image is not going to be georeferenced, right? It's just going to be an image. It's not going to have any innate spatial resolution, or it will have spatial resolution, but it's not going to have any innate spatial coordinates associated with it, right? And so that's what I'm sort of working up to, is then how do you give it spatial coordinates? How do you go through that process of georeferencing? Before I get into that process, or do you guys have any questions on anything that I've shared so far? Okay, I'm not seeing it. Again, this can be quite a helpful resource if you're interested in looking at change over time. So I've actually gone ahead and I've downloaded an older image. I think it's from the 1960s, and I've also downloaded another image. So the 1960s image that I have doesn't have any georeferencing information whatsoever. I've got another image, I think it's from like 1983 or something, and it does have georeferencing information. And that's one of the key things here. You need to have an image or some kind of so I'm going to open up a new ArcPro project here. And I'm going to just navigate to this guy, and I'm going to call this in class. Let me make a new folder if I can. Sometimes it doesn't always make the folder. It makes me mad. But we'll see if it does it. All right, looks like it took it that time. All right, and I'm going to call this guy in class. So we're waiting, it's thinking, and now I've got a new project. and hopefully you guys can see this, but I've got two images in here. A 2013, I take it back, a 2013 image that does have georeferencing information associated with it. It is georeferenced. And then I've got this 1965 image, which is not georeferenced. I can share these guys with you as a Google link if you want to download them and work with them on your own time and go through this process and check it out. I'd be happy to do that. And in fact, let me see if I can do that in the chat. If you want and you want to download these images and play with them, you're welcome to. They're pretty huge. They're pretty large. So that download process is not going to take a second. And you would want to do it on the processing computer you're working on. So if you want to work with the images that I'm sharing here, that's the link that should allow you to do it. But basically in my map, what I'm going to do is I'm going to add data. And I'm going to start with the image that has georeferencing information associated with it. It's this Hilo 2013 guy. It's asking you and everybody else about. Thank you, Avalon. That guy, why is that being that way? Let me make. So it should, if you access it with your hawaii.edu account, that link should work. If you access it with another account, it may be unhappy. I don't know if anybody else has tried with their hawaii.edu account and it's happy, or is it also asking you for information? Okay, Helen says happy. So if you access it with your hawaii.edu account, it should be okay. Again, if you're interested in downloading that information. But back to this guy. So again, the text is super tiny, but down at the bottom of the screen, down here, you can see these values, right? 280. You guys can't see. This is too tiny, but tiny spatial values as I move my cursor around, right? And if I right click, you guys know how to do this already. If I right click on the data set and I go to properties, right, and I go to source, it'll tell me information about this guy, like the raster and different things and the statistics and the spatial reference. NAD 83 UTM zone 5 north. You guys you're experts at this stuff now, right? So beautiful. And this is an important point. The first data layer that you bring into the ArcMap project, it'll assign that ArcMap project coordinate system to the coordinate system that data layer had. So if I right click on my map and I go to properties and I go to coordinate systems.
It's so much information. I'm not really.
This is the class I was doing the homework for.
So I might, if that's Helen, I'm not exactly sure, but I just muted her. I think we're okay. All right. But anyway, the point I was trying to make is when you open up an ArcMap project, the first layer you bring in, it will then assign the coordinate system of the map to that first layer, which is NAD 83 UTM zone 5 north, because that layer I brought in is that one. Okay, hopefully we're good at this point. Now I'm going to bring in this image, which is this 1965 image, which shouldn't have any georeferencing information associated with it. It's asking me about statistics. I'm going to say no for these purposes. So I just brought it in, but where is it? I don't know. If I right click on this guy and I go to zoom to layer, look at this. Look, this, I think you guys can see it. It's tiny. This is 4.36 east. So, and then 0.54 meters, north, right? This image exists, but it has no spatial information associated with it. So it's just like floating out in nowhere, right? We're at like 0 north and 0 east, right? It's just, I could zoom way out and sort of see where that actually is in the world, and I may break the machine. So we're just out in the middle of nowhere. Okay. So the tool that you're going to use to do this work, I believe, is under imagery. And it's this guy called Georeference. Okay, so under imagery, it's a tool called Georeference. And basically, what it's going to ask you to do is find a place on the image that you want to georeference, zoom in on that place, and click, right? So you're going to zoom in at some place that is visible in both images. It's like a tie point. So it's some kind of a point or location visible in both images that if you zoom in, it needs to be present in both images. So like out here, this is not a good place to click because maybe it used to be forest, but now it's been developed into buildings or such, right? Whereas a main, road intersection may be a better place to choose, or one of these buildings by the bridge or something might be sort of a good location. So if we want to get started here, we want to, and this is where I need to remember how to do this thing. There is a process for me to start doing this. And oh my goodness, and what is that process? It is not that, it is, oh, I want to add control points. I think that's what I want to do here. Okay, so from point the source. So again, under georeference, first you get that initialized, and you want to add a control point. And I think that this roof line here, right? I think this same building exists in 2013. I think we're going to find out. And I'm going to zoom in on this corner of the roof right here, and I'm going to click on my from point source. This is the image that you want to georeference. I'm going to click there. All right, now I need to go to that same place on the target. And the way I'm going to do that is I'm going to right click over here. I'm going to go to zoom to layer. And you can see, so that image is, floating way off someplace. If I zoom in, I zoom in, I zoom in, I think this is the place. Or is over here. I think it's this one. And you can see it sort of tried to bring it in, right? And so except it's really tiny now. Okay, so now the process is just to find another place, right? And when you want these control points, you want them to be distributed across your image. All right, so I'm going to go to another, and it's usually a sort of a bouncing back and forth between like, where is this? Do I see this point in the 1965? Do I see this point in the other one? So I'm going to just lay out a couple more points here to let you guys see, and then I'm gonna set you guys free and open up the floor for any questions. So again, the situation. Oh, so I think the airport existed in both of these guys. So I'm going to zoom into this guy again. And looks like, oh, on the airport runway, I get this guy. Has the airport changed since they built this? I'm not entirely sure because I would need to look, but this guy, what still exists for me? I think that this bridge is still going to exist. Or actually, let's do UH-ELO because that's where I'm currently located. If I go to UH-ELO, some of these older buildings, including where I am right now, exist in both this 1965 image and the current image. And the first place that you click, here we are. The first place that you click is always in the source image. So I'm going to click on this guy up here, this roof guy here. All right, and then I'm going to go back to this one. Find that same location, which is here, and click. Okay, and by doing that, right, they're starting to lay over top of each other. And now I've got two control points. I don't know how well you guys can see here. I've got one up here and one down here. You want to have a bunch of these control points distributed across your image. You don't want them all bunched in one particular location. And so, for example, up in this area, And now it's easier for me to turn these guys off and on and sort of see what's going on. And you can still, there's still a shift here. So there's still a shift associated with these guys. But the more control points I add, the better off things may be. So it looks like this bridge overpass might be a good place. All right, so I'm going to use this guy. It looks like there's some vegetation in my way, but I'm going to go for it anyway. This is 1965, and then this is the 2013. Oh, didn't like that too much. Those is, oh, it flipped it all around. That's pretty wild. It flipped it around. So once I bring in at least another image, it should rectify that. Actually, that's a little bit wild. I want to see my control points here.
I think you kind of answered this in saying that the more georeference points, the better, but is there like a bare minimum that you would generally recommend?
Yes, and I don't know how well you guys can see here, but the transformation value that's given, or the way of doing this right now, is called this first order polynomial affine. That's the really, and that allows you to shift and then rotate and scale. As you add more control points, you will be given more options, including a second order polynomial or a third order polynomial. You need to have at least 4 control points, I believe, to get to a second order. And then once you get beyond maybe 10 or 12, you can get to the third order, I believe. What's really critical is that the control points are placed as precisely as possible. So you really want to zoom in, and you don't want to do this sloppily, right? You really want to do the best that you can to make things line up as beautifully as possible. And in general, the second order polynomial is seems to work quite well. So I just need to find some more things that can help me. Oh, we can do Coconut Island. And interesting that, so this is before there was a bridge, right? Pretty wild. So I'm going to click here. All right, so I've got these guys. Let me just get a few more going on here, and then we can see that my options for, so I've got the 3 enabled. If I bring in the 4th one, yeah, there's this 4th one up here. Let me see if I got anything out in this direction. So any of these houses, yeah, it's quite interesting to see these, at least in my mind, to see these changes. This is probably a reasonable intersection that hasn't changed too much. Or is there a school? Oh, there's a school up here. Let's go for these guys. So this is I think this is De Silva Elementary School up here. So I'm going to go to this guy up here. Again, roof corner. And I'm going to go to that same location over here as best I can. In this table and up here, it'll give you the sort of error associated with your points. And so this is telling you that, oh, there's about 25 meters of error, the sort of root mean squared error. It doesn't sound very good, right? That's a lot of error. But now that I still only have the first order option. So let me get a few more points here to get the second, and then I can let you guys free here in a second. So let's go down in this area. This looks like YK, maybe YK Elementary School. It's changed a bit. I'm going to go for this one. I believe is this one. And they may have re-roofed things a little bit, right? So now I've got the option for the second order polynomial. So right now I've got my first order polynomial guy. I've got 6 control points, 23.75. Those points are distributed, somewhat well across here. I would like some points up here. I'd like some points in the corner. I'd like some points in the middle here. But if I change this from first order to second order, you see there's this pretty crazy shift that just occurred. But in some of these locations, if I zoom in up here and I go from first to second, right, you can see that there's a little bit of a shift going on here. And this is the second order. What we see here, bring that guy back. That's the second order shift. And then if we jump this guy to the first order, you can see that there's a little bit more of a shift in the, I can at least, in the first order than there was in the second order. So I would definitely, if I was going to keep on doing this, I would add, typically when we do this for projects, we will have, for an air photo this size, we might have 50 plus ground control points, tie points that we use to register the image. As you get further back in time, it becomes more challenging because there's less and less structures and things, right? So you really want those things to be the exact same location, right? And so roads get repaved and intersections get widened and buildings get demolished and then new roofs get put up. So these different things occur. So you got to be somewhat careful. And oftentimes what we'll actually do is we'll do sort of a progressive thing where we start at the present and then we go back to 2000. And then we go from 2000 to 1990, then 1990 to 1980 or whatever, right? Because presumably there's going to be this continuity of structures and change across time rather than jumping directly from 2021 all the way back to 1965. But that process, and then once you're done, you can save it. You can keep on adding control points, which I certainly can go through the process, but I think you guys get the ideas. And then once you're happy with the amount of error that you're seeing here, and again, I'm not that happy with this error yet. I think it's too high. And I think 6 is probably the minimum number of control points to get to the second order polynomial. I should probably add some additional ones, and then we'd actually get some values here that make sense. Then you can basically save it, and then you can have an error amount that you can report, and then you can presumably use that document to do whatever it is that you're interested in doing for your work for your project. Okay, so that is basically what I wanted to share with you guys in terms of this georeferencing. I will make the point that this is also known as rubber sheeting, where you're basically kind of stretching or modifying the image to fit another georegistered image. There is a more comprehensive process called orthorectification that is more scientifically sound. And that basically takes in topography into account in this process. And to do that, you need a digital elevation model to go along with the images that you're working with. But that digital elevation model allows you to sort of take into account topographic differences and valleys and gullies and cliffs and whatever else. And it allows your orthorectified product at the end to be better than simply what we're doing here, which is called kind of georeferencing or rubber sheeting. It's kind of a dismissive term, rubber sheeting. But with good ground control points, you can tie them in pretty nicely and get a pretty good product. Again, at this point, I've got 6 points. I would probably want 3 or 4 times that at a minimum to be more happy with the product. Okay. So unless there's questions, and if there are, I'm happy to try to answer them. That's pretty much what I've got for you guys today. Again, I've got office hours, and your lab 2 submissions are due this evening. I see that a good handful of folks have already submitted, so that's great. And yeah, so that's what I've got for you guys. So I will stop recording. And if I can figure this out.